after Lee's speech. So we'll just going on with the schedule. So we'll get Lee, you, and then Simon. All right? Thank you. Yeah. You're on.
Yeah, there. Let me see. Okay. Thank you. So hi everyone, my name is Andy, and the topic I want to present to you today is highway to the external world, generate externs programmatically. Oops. So yeah, first of all, some information about myself. I'm from Hong Kong. Where's my mouse? Oh. Yeah, I'm from Hong Kong, and I spoke at WWX 2005 last year about the topic of continuous integration for HAS projects. Nowadays, I'm working full-time for the HAS Foundation, responsible for a number of things. For example, the jQuery extern, which is one of the main contribution since I've worked for HAS Foundation is generated from the jQuery documentation API. It has been merged to the core standard library since HAS 3.3. And then I also is responsible for the continuous integration for the HAS repos, namely, Travis CI and AppRayer. And in this year, I also took over the maintenance of the HAS and the Nickel packages in the Linux distributions, and also Homebrew for Mac, and also the Chocolatey package for Windows. And I'm also responsible for a few things like HASLib and also the backend for the websites. Although, I officially took over of it, I don't have much time to work on it at the moment, but I will look into that soon. Okay, thank you. Yeah, so let's travel to the external world. So yeah, in order to use native libraries in HAS, you have to write these kind of extern files, which tell the types of the native library to the HAS compiler. It's required for, of course, for dynamically typed targets like PHP, Python, JavaScript, and Lua, and it is also required for C++, although it's statically typed. However, the HAS compiler currently do not really consume the C++ header files, so we need to tell the compiler about the type information in some way. Having up-to-date and accurate extern file is very valuable, and it's very important, I think. Firstly, I think that it enables us to interface a native API in some way. And because each platform or each target has its own capability, that they has their own APIs. And then to use those APIs, we need those extern files. And secondly, there are a lot more library out there that is not written in hash, but in the target language right now. I believe that it will improve in some way because hash is becoming popular nowadays. And however, there must be some nice library that is not written in hash, but you still want to use it. And we have to use external files for that. Thirdly, external files are very useful for us to interface the legacy native code. For example, if you have existing application written in PHP that is deployed to a PHP server, and then at some point you want to port the application to hash, you can do so by just writing the external file of your PHP code first, and then you can port the classes and modules one by one to hash, and then you just use the external file to bridge between your existing PHP application and the new rewritten hash code. And actually, what I'm proposing for to generate externs programmatically is not a new concept. It has been done actually in our hash standard library. For example, the Flash API is actually generated from the players global.swc file, and also the JS.html package is generated from those IDL file, which stand for interface definition libraries, I think. Interface definition language. And that web IDL is specified by the W3C, so the information is very accurate. Originally, it was generated with WebKit's IDL file, and then nowadays is generated using the Mozilla's maintained IDL files. And also, I have mentioned that the jQuery extern living in the js.jQuery package in hash 3.3 is generated from jQuery's documentation, which they have maintained a machine-readable XML format of their documentation. So I just put that in and then process it to generate the external files. And then maybe in the standard library one day, I've been working on a little project called PyExtern, which is try to generate the external files for arbitrary Python library. I will talk about that, how I did it. So yeah, let's take a look at the approaches we used in the existing works. To generate a set of externs, first of all, we need some source of information, of course. For static typed language, for static typed targets is kind of simpler. All we have to do is to look at the source file, either the source file or the compiled binaries, because it's static typed. All the type information is embedded in the source file or the binary files. So we just have to parse them. And for dynamic type targets, it's a little bit more complicated because, well, they don't have very concrete notion of types. At compile time, at least. So what we do is to fall back to look at some other information. For example, we can parse the documentation. Sometimes they will tell you that a particular field is typed as string or integer or something. We just have to get those documentation and then convert it to a hash type. And this is the way we did for the HTML extern and for the jQuery extern, basically looking at those machine-readable documentation. But if there is no such information, it's not the end of the world. We can do one-time reflection. Actually, for PyExtern, I use this method. I collect the structural type information by reflection using a Python module named inspect. It's a Python module inside the Python standard library. Yeah, it's kind of like the has reflect class, but yeah, just a different name. It's called inspect. It gives us the list of modules available in the Python environment at one time, and then also the list of all the variables and types and each Python types, and also all the fields in each types, etc., etc. And then with this information, actually, we can already generate a usable extern. And then yeah, similar approach actually can be used for the JS target and Lua and all targets that support reflection at some point, so that you don't have to actually parse the documentation. You just call those reflection API to get those information for you. And of course, there are other approaches that is you can be creative to try to actually interpret the target language source code or to infer the type in some way if you are really hardcore. But I'm not, I haven't tried that. to the approach I used is that same as to build a minimal viable product, to try to have something working that you can immediately use before you have all the accurate actual types. So to try to get the structure correct first. What I mean for structure is the name of the types and all the field names, the available field names and method names. For all other stuff, for example, the type of the variables or the types of the function, the return type of the function, the function argument types all can be dynamic. You just specify it as dynamic first at the first step, and then actually with dynamic you can already use the native library in some way, and then later afterwards you can try to refine it with some more accurate types. To give the actual types for the field types and function types, function return types, and then the next step you can figure out the function argument types, and then at some point you want proper inheritance to reflect that in the external files, and then you even can pull the dot strings in the native library to the external files. And if you really want, you can have a HESI wrapper such that it's easier to use, but there is a later stage. What we should try to do is to have the structure complete first. So yeah, after we got all the information we need, at least the structure of the native library, we can start to generate at the .hx files in some way. And one little tool that is very helpful is the has macro printer class. Actually, you just there is an API that is named print type definition. What is input is that you give it a type definition instance, which is kind of a proper AST of the has type. You feed it to it, and then it will print it as a string, and then you just dump it to some files, and you kind of you're done. So yeah, we only have to learn how to build those type definition instance, and this is actually a very useful knowledge because you can reuse this technique when you are building custom types using macros, because there are the macros API has macro context defined type or has macro context defined module. Also takes those type definition instances as input to create custom types. So this knowledge is not just applicable to generating externs, but also for macros. So once we have generated some extern files, it's time for testing. You know, well, we love testing, and to do so, it's kind of simple. We can just run the Hash compiler against all the generated files, and the compiler will just check all the syntax or whatever for you. Two very useful compiler arguments is that one of them is dash macro include package name, and you just include all the generated native extern that is inside a package and feed it to the Hash compiler in this way. And then you may also use dash no output, such that you are just checking the type and the syntax. You don't have to really output any program for extern, because externs is, well, not meant to be output anyway. Yeah. And then we can just use the extern files we have generated, and then once you have used it, your application automatically become a test case for your extern generator. And then at some point when you refine your extern to have more accurate type and stuff like that, if it breaks your existing application, you will know that there is something wrong, and then you can refine your generator. Yep. So at this moment, we already have a set of extern that has been working, and when we test, we have some minimum testing, and then it's time to have to improve it. To have more accurate type, instead of using dynamic for everything, we have to look at some other information. And as I have mentioned, for the PyExtern project, I've used the inspect module to get extra information. The inspect module has an API called get.dot, which return me a dot string of the Python module. So I don't even have to pass any documentation. I just call it in a Python environment at runtime, and then it will return me the dot string. And then because a lot of Python libraries are written, the dot strings are written in a format called RST. So I use a Python library called dot routines, dot parser, dot RST, dot parser, that will parse the documentation to give me an AST, and then I can just figure out the type information inside the AST. And once I have the type string, maybe it's called integer or string in the documentation, I can already try to map that to an hash type. For some simple things, it's just trivial. For example, integer, string, or numbers, all those have equivalent hash types. It's just trivial. For something a little bit more complex, for example, maybe the documentation say that it's a string list or it's a string or integer, then well, we can still try to process it to come up with something meaningful in hash. And although it's a little bit complicated, but you can still figure out some way to do it. The real trouble is that sometimes in some library, in some types, in some class, there are actually no documentation on types. And then even worse, sometimes the documentation is just incorrect and it's not accurate. It exists, although it's not very frequent, but it's kind of troublesome. And we have some ways to deal with it. I will talk about that later. And but anyway, the bottom line is that when we are not sure about the type, when we are not sure about the documentation, documentation, we can always output dynamic, and then just output dynamic, and then just use the native library as you wish, and then just work around it. So there are sometimes there are unknown entities in the documentation, or the information is missing, and then we can use dynamic for that. And then one little tips for you is that I think it's useful to have a specific type, maybe type def unknown equals dynamic, and then you can let the generator to output unknown instead of dynamic for all the types that you are not sure. And then in this way, you can just look at the extern file that you have generated, and then you can see, well, for what field the type is still unknown that you have to improve. And then the objective is very simple for you now. It's just to reduce the number of occurrence of this unknown type in the extern generation output. And then another idea is maybe, well, you can have even more advanced type, maybe using macros in some way, such that you can write unknown list of string, the documentation embedded as a type parameter in the unknown type. And in this way, even the generator don't know that list of string is list of string. You can the user of the generator extern can still figure out the type without looking at the native library's documentation. They can discover the type by just looking at the extern. At some point there will be those types that are not documented at all, or the info is incorrect, that we have to patch it in some way. And this is kind of a way to hard code their types, and we can do so by some type with some form of type patching. And actually, we have used type patching for generating the Flash API. Nicholas used a special .patch file that has all the special modification on top of the native API. Like, for example, there was a lot of enum nice value in the Flash API, and then we want to use the hash enum for all those values, and they can do so. They can specify it in the patch file. And also, we can remove all those not relevant problematic special types from generating to the output by using type patching. Concretely, how to do so is that we can do so in the time mapping function. And this is the actual part of the jQuery extern generator that I've used. This is the function that map an input type, which is encoded as a string, and then we output it as a list of complex type instances. So the input is a type, which is the human readable documentation, and then there is another context variable, which is test, which is named tet, which is an XML log. And then from that tet log, we can extract some other information. For example, what is the currently processing method name or type name right now. And then by mapping the type, we can just use a big pattern matching with all these three info of the function name, the type name, and also the name of the type. And then we can hard code all the manual type patching stuff inside that switch. Although it could be troublesome to do this hard coding the types for every type, when there is not much type information in the documentation. But I want to point out that actually it's not that difficult comparing to writing the extern manually, because when writing the extern manually, you have to map all the types in some way anyway. But if you have all this logic put into the generator, when there is a new version of the native library is released, you can just run the generator again, and then you can have a new set of extern immediately. But if you write it by hand manually, you have to go through all the logics, and sometimes you forget all the little tricks or all the little tuning adjustment you made in the previous version. And it's actually funny because if we generate a new set of extern for a new version, we actually it's not just we don't have to keep track of the changes in the upstream library. Actually, when we generate a new set of extern, we can commit it to Git, and then by Git diff, we can actually observe what is changed in upstream. So actually, that's all the little tiny tips for generating externs. So first of all, why should we generate externs is that we can achieve very high API coverage very easily. And then it's very easy to update the extern files when a new upstream library has been released. We don't have to keep track of the change. We don't have to look at the change log, and you know, library authors seldom have very accurate change log whatsoever. And it's not difficult to do so. The effort is kind of similar to writing the extern manually. The technique we use is that we can get all kind of information from all kind of source. We can get it from documentation, or even get it from in one-time reflection with the target language support one-time reflection. And we can generate the extern by using build up type definition instance, and then we can feed it to the has macro printer that will print all the things for us. Just don't try to print out the hash syntax as a string manually. It's problematic. And the approach we use is to have the structure get right first. We can just output dynamics for everything that we are not sure at the early stage. And then later, when we have time, we can refine it with more accurate types. And then for everything that is hard to be automated, the information is leaking in documentation, we can use some form of type patching. We do so by having inputs, the time name as input, and also with context variable, such that you can just pattern match with those info to output a correct type. And well, although we have all these techniques, actually is still difficult, to be honest. And but I believe it's not the problem of the approach we use. Sometimes I think it's problem of the hash type system. It's already pretty good because it's very similar to all the other languages. We have class, we even have enums, we have static methods, we have variables, all those kinds of things. However, there are some features that is hard to model in hash. For example, the array access operator can only use integer keys. We cannot use string or some funny values like in Python. And We can do so by using abstract, but abstract has its own shortcoming, which I will talk about that. We don't have operator overloading. With the native library, use operator overloading, which is quite popular in Python libraries and also in, I don't know, in Scala or something. We can also use abstract, but well, abstract has its shortcoming that abstract is poor at OOP inheritance. We cannot really model the inheritance with abstracts. And there was some problem with structure types. Again, there are no function overloading, and there are no array access. And structure types are not callable, and it's common for example, for JavaScript libraries to have closure that are callable, but they have their own custom fields. That is a little bit hard to model, but you know, JavaScript is structurally typed, and sometimes you really want to use a structure instead of a class, so you cannot use those self-call metadata or something sometime. And in some language, there are non-nullable types, and all those C++ reference, pointer, const type are tricky to deal with. Although I know that is improved a lot in recent years in HCPP, but yeah, just to watch out. So for future works, of course, I have to complete PyExtern. Currently is usable. It outputs a set of usable extern for arbitrary Python module. I have a command line program. Yeah, it's a command line program. You just input the Python module you want to generate extern with, and then it will just dump it to a set of files. But still, currently it output dynamic or unknown types for a lot of places, because it's kind of difficult to pass all the documentation correctly, and you know, sometimes the documentation are not written in the same format. Sometimes it's RST, sometimes it's just plain string. Yeah, I have to complete that. And then, of course, later we can extend this approach to other targets like JS extern, PHP extern, UI extern, etc. And yeah. And then hopefully my wish list, my feature request is hopefully we will have a more powerful and flexible extern type system to accurately to annotate all those array access or operator overloading in extern cars. And I would like to use this chance to call for contribution. We really need some help right now. First of all, for manpower, actually, the HASS Foundation is really a small team right now, and we are loaded with works. I have been busy with working to clean up nickel and sleep and yeah, all kind of stuff. And Simon is filled with all the maintenance work for bug fixing and to take over the whole release cycle. And Nicholas and Kari have their own full-time job, and they are not working full-time, particularly for the HASS compiler. So we need more manpower to look at the compiler source code to maybe to contribute in some way. If you are not really up to looking at the compiler source code, you can at least help us with documentation and go through the documentation to correct the information, and yeah. And we need money. Sorry about that, but at this moment I'm working full time for the HASS Foundation, but very likely in the next year I will switch to half time maybe. to work on has issues and other has things. Just because the HES Foundation is running out of money, we don't have enough sponsor. So hopefully, if you are a big company that using HES, well, consider sponsoring the HES Foundation, or just, well, know that, be aware of that we are making money. And then the last point is marketing, probably the most important points that you can contribute, because, well, if you help us to grow our community, we will potentially have more contribution financially or in manpower. If we have more people to use it, well, then definitely we will have more contribution in some way. Yeah, basically that's all for my presentation. And if you have any question, just ask me right now, or you can reach me via Twitter. Thank you.
Wow, any question? All right.
Any question? Okay.
Have you considered using that TypeScript extern generator?
Yeah, sure. Simon has a has a converter that that convert TypeScript definition files to HES types, but I haven't really tried it actually, and I really should. And maybe Simon is suggesting we shouldn't, but I don't know.
Well, I think the problem with the TypeScript generator is that we took the wrong approach because we had to write the TypeScript parser in hex. And TypeScript syntax is actually getting pretty complicated. There's a lot of things that we'd have to support. And we were talking about it, and it's a better idea to somehow get TypeScript to generate the hex externs. And so we don't have to do the whole parsing thing. And we could still use what you're saying, hex microprinter, because we can just generate it to JavaScript and then use it from there. And overall, I think that's a better approach. It's just something that someone has to do. So if someone wants to contribute, please go right ahead.
Yeah, I know what you mean. And actually, I think I have looked very briefly into the TypeScript compiler. And actually, it's written in TypeScript, so it's actually callable from HES when we target JavaScript. Maybe we just, well, write an extern file for the TypeScript compiler, and then we can cook the extern generator in HES, and then consume the TypeScript compiler, yeah, in some way. Yeah, probably.
Anyone else? Okay, thank you, Andy.
Thank you.